Hello everyone and welcome to another Snake Sunday stream. Thanks for joining me. Last week while we were working on implementing this Monte Carlo tree search in Rust, and we're gonna continue that today. I think first we're gonna take a look at some of the comments I've left to myself in the last week on this PR here, and then eventually I think we're gonna get into making some visualizations here to try to understand the tree that we've made with Monte Carlo a little better and make sure that our code is actually doing what we want it to. So let's dive right in. So let's make font size bigger. This is what we worked on last week. We added the Monte Carlo tree search, and I left a few comments for myself that I think we'll want to dig into. And the first here is kind of a bug that I realized was happening. So let's dive into code here. That's on line 130. So what's happening here is we are in our Monte Carlo loop where we're looping until we've taken 400 milliseconds. We give ourselves 100 milliseconds of network latency padding. So out of the 500, we're going to take 400 to Monte Carlo. And down on line 130, so actually when we're done doing all that looping, we need to pick the best move for us. And we're currently using this best child method. But according to my comment that I left myself over here, best child doesn't do exactly what we want for that use case. Its best child is defined to use the UCB1 score of the children and pick the highest, and this is the best when we want to find the next leaf node to explore in Monte Carlo, but it's not the highest average score, which is what we want to do when we choose the node. And I'm going to fix this quick so that we can get some games running in the arena with our new fix. We're down here at 37th, hanging out with about a 33% win rate. And I think we can make this change, and I think that'll boost it up a bit, because I think right now we're always choosing the move that we'd want to explore next, but that's definitely not the actual best move. So we're going to fix that quick, and then we will push up a new thing, hopefully while these games are still running. 40%, yeah, we should be able to get at least the second half of these games with some code changes, hopefully. So first, I think I want to rename Best Child, because Best Child, I think the name is what screwed me up last time, and that's why I picked this method without realizing it didn't do what I wanted it to do. So this isn't Best Child, this is the next child to explore. This is the next child to explore because it finds the maximum UCB1 score, and that takes into account how many times we've been to a node and things like that, which makes sense when we want to keep exploring nodes, but is not right when we want to just find the best move based on the tree that we've already made. Okay, so now we have that renamed. I think now we're using next. Yep, okay, so the rename propagated through, but we don't want to use best child to explore or next child to explore. Best move child or something. Highest average score child. We'll just be pretty explicit here. And another thing that was a little weird was that before, to get the what I thought was the highest average score child, I had to pass in the total number of iterations, which didn't really make sense for trying to define the move to pick. But now we don't have to, and that makes a lot more sense for this API, which is nice. I'm just copying the signature from the method above it. Yeah, so I don't want to check has been expanded here. I don't think that is what I want, but I think I'm probably gonna want these two. Oh, so close. Sometimes I have to try to beat Rust format, and I did not win that time. And actually I almost want this whole thing too. And we just want child dot average score. Which doesn't exist yet, but we can define it. Generate average score method. Go to the definition. Put it in the wrong spot, but it always does. Awesome. We want to return, I think we want to return the same F64 like we were doing before. And I think in this case where number of visits equals 0, we actually want to return like negative infinity. I'm actually not sure. Is there a constant for that maybe? Negative infinity, perfect, okay. But I need number of visits as a let, or just different than I have it at the moment. Okay. Okay, now it's mad at me because I don't do this at the bottom. Gotta... if you're on stream and hanging out, let me know how my mic is. I keep having to move it out of my eyesight so it doesn't keep bothering me. But let me know if that made it too quiet. Okay. So now in the average score, if there aren't visits, we just take 0, or we're gonna take negative infinity. And I might want to have this return an option kind of, and let someone else on the outside decide that. No, and we're also gonna say if number of visits is 0, your score's just 0. Do we want that? No, because we do have negative scores, so let's go with the smallest possible value, which is gonna be negative infinity. I guess maybe what would be best really though is to make this an option, and this should just return none. Because giving it a real value was kind of making average score decide what was best for all of the use cases, and I don't think that's actually what we want. Let's just bring those. Average scores that, and then we just return sum of average score. Awesome. Can't divide by usize. That's because I need to make it an F64. I do that here. Awesome. Could replace some of this with just a call to average score now, but I don't know if it matters a ton. No, because I still need these lets for other things, so we're just gonna leave that alone. But let's write a test for average score because it just seems like a nice thing to do. Here's where I tested some UCB1s. Let's take these same test cases and test average empty score. Average score. We only get 1 because we don't pass anything into these. Oh, and actually, let's just go with an assert equals. I can make my case not be a decimal, that's hard to represent. Awesome. This needs to say average. Oh, okay, cool. Check that it's a sum. Actually, no, in the empty score case, this is going to be none. That was the whole point of making it an option. And in this case, I think it is actually sum of 10 because we're doing 10 divided by 1. Perfect. Let's just cargo test that. Oh, cool. From option U64 is not implemented for constrained float. Oh, okay. So in average score, I told it I wanted to return an F64, but I have a constrained thing, which means I probably have my what do I want to do? Average score here, just an F64. Wait a second. Oh, I told it to from that. Got it. Got it. And it doesn't know how to from that, so a filter map? Children dot, yeah, I think I want something like a filter map here. Filter map to, oops. So we take a child in the closure, we're gonna filter map it to child dot average score, and then we map the average score. So here's what we're gonna do. um, child, comma, average. Yep. Because of this, then now I can go child, comma, average. This just becomes average that I've already summed, and now everything is mad. Yeah. Because I need to map from the child. No, map to, this thing, I guess. Nope. Yep. Yep. We have an X. Come on. Typing. There we go. And I want to do X dot. No, I've already mapped it. Okay, so it's definitely a thing here. Yep. Sorry. I can just take this apart here. And I just want the child. I don't care about the average. You can do that. Filter map. Okay, it's mad about me not closing things. Okay, so where's the unclosed delimiter here? Something is upset with me. That closes that, that closes that, that closes my filter map. There we go. Oops. That's not what I wanted. I wanted that to be inside. Perfect. Yep, I don't need the child here. Awesome. That's an interesting point. Can you take the max of a none and does it do the right thing? I have a number and an option and you replace it with the max value of it and some other value or use the value number is none. If it's some map or order, we'll compare. Since thus comparing, it's possible to implement your function like this. Sum t is greater than none. Perfect. Okay, so I actually don't even need to be doing most of this. Cool. Yep. Oh, average scores still it thinks is unused. But I used it in test. Okay. But let's just plug this in, I guess. That was on line 130 about. Yeah, so instead of next child to explore, it's highest. And then it doesn't take in anything. Awesome. Awesome. Okay, the test passed too. Let's make sure they actually tested sane things though, and then we will. Let's just do. Woohoo! Awesome. Fix bug where we were using the UCB1 score to pick the best child at the end of Monte Carlo tree search instead of the average score. Now we should actually pick the move we think is best instead of the portion of the tree we want to explore next. And this might not actually make the biggest difference at the base of our tree like we're at, but I don't actually know. Maybe the visualizations that we're going to work on today would have helped know the answer to that, but I'm going to fix this first because I want to get it playing in some games. Awesome. And I think we're going to do the other thing that I mentioned here too, which we have this clone that we don't need, and I think after thinking about it, we can replace it with a cow, a copy on write in Rust, and I haven't done that as much before, but I think I know what to do, and it should be a nice easy cleanup. So let's look for this clone. Might not be the best. Perfect. So what we actually want here is we want to say that the current state is a cow of T. Well, let's see how to actually create an owned thing of a cow. Cow from should work. Ah, yes, I've got to tell it I'm talking about cow. Yep, okay, so now we have that, except now I can just do cow from next state. Cool, let's see what I did wrong. Just trying to find some better examples here. Okay, so they do use the things directly, so I'm gonna do that too. I'm gonna say that this is an owned, and this is a borrow. Borrowed. Ah, sure. Reference to next state? Oh, yes, okay. Wait. Oh, these are backwards. This one I want borrowed. This one's owned. Owned. Yep. None of that. There we go. Does that still compile and test? Yes, it does. Awesome. Nice. Why are we cloning here? Nice. No need to clone there. Boom. Killed that clone. Do we have other clones? Yeah, we do have some more clones that I could maybe end up getting rid of, but I'm not positive. Okay, well, we got rid of the clone that we were worried about with our cow. That was pretty easy, especially since I actually never transitioned between borrowed and owned here. I just needed a type that could be either. And I'm never writing, so I don't need the copy part, which is nice. Remove an unnecessary clone by using cow. Okay. I think I'm ready. Actually, no. Let's run some local games first. So let's run. Oh, cool. I have a whole nother. Let's close you. Cargo run, bin web axum. Let's get our web server running. Let's go to a medium game board. Add Monte Carlo. Let's add local hobs. And let's run a game. Okay, well, we at least have it running. And then Hobbs takes the lead. That's actually interesting though. Why? This game is over, no need to keep going. Oh yeah, because it looks like Hobbs trapped at the Monte Carlo in this little like box up here. But that's interesting then that that's what Monte Carlo chose to do. Let's just run another game and see if that was a fluke or if the Monte Carlo needs some love. And if it does, we might just work with the visualizations that I'd planned anyways, because that seems like the best way to find out what's wrong. This game seems like it's going a bit better, so that's good. Yeah, this is definitely at least a longer game. Okay, we're doing pretty decent here. Nice, nice. I want to wait for this game to run. It's fun to watch. Hangout gives me a sec to think about where we're going next. I think we're gonna get some graph viz stuff going with some rusts. I think maybe dot is the crate. I took a look. We'll take a look again and see which one we want to pick. Uh-oh. There we go. Game is over. No need to keep going. Yep. Okay, so Hobbs just decided the game was over, and that's basically all the logs we get at the moment. Why is it over again? I guess it's kind of that same thing before. As soon as we locked ourselves in here. Yeah, I think that turn might have been the death. No, it might be farther up. What turn was it? Turn 13. Whoa. Oh, that's from the previous game. Haha. 176. Yeah. This is the one where I was over. This one, oh, I could have, Monte Carlo could have gone up and escaped out this way. Okay. I'm gonna call this success, though, for bug fixing. Let's get a deploy out. Throw it at fly and give it a remote builder so it doesn't impact us streaming here locally. And I think while that runs, we're gonna take a look at what package. Oop, oh, 502 from lib.rs. It seems fine on a reload. So I want to make something that we can use in GraphViz. And there's a few packages. It looks, though, I looked at this one. Dot looks like it might be a good one. There's also dot 2, which basically looked like a fork of it. We'll take a look at both of those. And maybe, I'm actually not sure what a skill tree is in this case, but maybe that's what we want. Let's take a look. To show roadmaps. I'm not really sure if that's what we want. Parts of a skill trees, types, items. Yeah, but like, can I actually just see one? Ooh. Okay. Oh. Okay, there we go. We got zooming working. Well, this is pretty cool, but not what I want to make, so, you know, okay. I don't think skill tree is perfect. So this dot avius, I'm not sure how to pronounce that, but it looked really simple. Just kind of use this graph builder, and then that eventually ends up when you print line it. Okay, this one looks easier to use to me than dot did. By walking a labeled graph is can then automatically, yeah, okay, I know how graph is works a little bit. So let's look at their simple example, but I kind of think their simple example isn't all that simple. I looked at it earlier this week, but maybe it'll be easier in practice. Oh, and this is dot 2, this is the fork. I'm not sure that's bad or not, but definitely something to look at. So it all works by you have a thing that implements labeler and a thing that implements graph walk. Where node is the subgraph doesn't exist. Okay, I think we're gonna start with this one. You can just add node, add edges. It seems a little easier to me. Okay, so I think we're gonna use this package. Oh, we're still deploying here, that's fine. The other interesting thing is I'm not exactly sure how we want to output these. So what this is actually going to give me is just this dot file, this dot language file that GraphViz can understand. So I still think we're going to need something. We're either need to write that file to disk, which is probably what we're going to do. We can write it to disk, and then we can run GraphViz on it. But we still need to figure out like when we're writing to disk. Are we just gonna do this during our normal web requests? How do we want to handle this? This is also gonna be pretty expensive. Like we definitely don't want to be producing these in a real game. So, what do we want to do? Just taking a look at our current code. Like it would kind of be nice if I could hit a new endpoint, and in that new endpoint we could, you know, like have a move endpoint and a graph endpoint maybe, and the graph endpoint would throw some files on disk or something like that. So maybe we'll do that, but let's actually first, we got the deploy. So let's run a game on the interwebs and just see how it's looking here. Same people that we did locally. Let's put them in a wrapped game. Sounds fun. Just add some of that. Cool. Monte Carlo at least knows how to do some wrapping. Latencies are looking great on both of them. Nice. Oh, ran out of health. Yeah, see, so the Monte Carlo doesn't always know how to find food the best. And with the hazard damage, it very quickly can run out of health if it doesn't, you know, get away from those hazards quick enough. But I think that's working pretty well. Let's actually check out the honeycomb dashboard that we should have. So let's see, we want to look for something for our Monte Carlo. Let's just start with that. Log request on the make move, perfect. And then make move. I wonder why. Oh, because I forgot. I have two things named the same. But we can see. Oh, 817 total iterations. That feels like a lot lower than I thought before. Let's see if I can graph this. Nope, that didn't work. But this is on make move. Okay, so service name web axum target. Okay, let's add this. Show only valid. Yep. Okay, so factory name doesn't make as much sense there, but that target does. Oh, super interesting. Like, look at that. Sometimes we have 2 million and sometimes we have under 1,000. Wow, okay. I want a heat map of total number of iterations. Super interesting. So we do get some that are really low, and then we get some games where we get up to 2 million. Wonder if those 2 millions are real, or if we're like already at the end of a game. Like, I wonder if this is my runaway conditions that I would used to have in min-max, where like we'd keep essentially doing the same depth over and over and not actually making progress. Not sure, but very potentially, I feel like. I think another thing that I don't actually send that I would like to know is what the depth of the chosen like there's like a path that we're kind of choosing in Monte Carlo. We don't actually choose the whole thing, I guess, but you know, if we followed the average all the way down, I wonder how far of depth we're getting. And I don't have that now. And I like, that could be something interesting to add, but I think I'd rather try to do some of this graphing stuff. So let's work on that next. But let's just see. I think because of how I've constructed this, it would be a little hard to add something for just graphing. But maybe not. Like, maybe I can just do this. Let's make a graph endpoint. We're going to say, I think we're just going to copy move at the moment. And actually, we don't want snake name graph. We're just gonna Monte Carlo tree search graph, because that's the only snake that we want this to work for. Missed my, there it is. We aren't going to extract the thing from there. Monte Carlo tree search. Okay, what's the factory called? Wrong lib. That's the right lib. This is what it's called. Okay. Oh, yep. Oh, yeah. Okay. This one is route graph. Not found. Import you. Now you're found. What do you mean by that? I feel like there is though. Do I need to just import something? Import. Yay! Okay. Cool. Let's not actually call that make move. This is gonna be called graph move. Awesome. Okay, so now we at least have a place, except we're still using the factory. And if we use the factory, we're always gonna get a boxed snake. But I can just write an impl for just the Monte Carlo factory. Yep. Function from wire game unboxed. Takes the same thing as this, but instead of outputting a boxed snake, it outputs a Monte Carlo. Oh, see, this is the thing where now I don't have a T to write. I've done this before. No, maybe this is fine. Yeah, maybe? No, it's not, because I don't have... yeah, I need some indirection to happen so that I can get the different boards out of this. I really need one struct that wraps both of these so that when I'm generic over things, things still work right. That's a fun thing to play with eventually. Well, one thing I can do is just move this whole thing to yeah, maybe we just want to care about one of these at the moment. Like, maybe we're just gonna pretend that we only care about a normal game. Because one thing that I actually don't want here is just the, oh man, I don't want my boxed snake trait because then I don't have access to everything I need. Game info. Okay, so now I have a snake. I have a Monte Carlo tree search snake. Awesome. Oh, cool. So that still works the same because it does actually implement all those same traits. Cool, and now I can call graph move, which shouldn't exist yet, but I can make it exist. Okay. Making progress. Awesome. Oh, okay, well. One, you're still mad that this is just broken, but I don't need you, so that's okay. Unused import, method not found. Okay, the unused imports I am totally fine with, because that's the whole point here. In web accent is where we have missing things up top, like we can remove the unused one. We can, oh man, it didn't want to, sometimes it doesn't want to do things for me, which is weird. I don't know why it didn't want to just remove that for me. Oh, okay. 157, I need to make myself an ID map. Yep, I need a reference to the game. Awesome. Graph move still doesn't exist, but that's now my only error. Awesome, awesome. Okay, so let's go to here. Here's make move. And I actually do just want a impl for just for this Monte Carlo tree search. Yeah, because this is implementing Battlesnake UI for these. So I want something that's kind of similar to this, but not exactly. I'm not implementing anything for it. I just want to implement this. Cool. So now I have this empty impl block. I'm actually going to take a minute or two here. I need to run to the bathroom stream, but I will be right back in just a few minutes. Thanks for hanging out while I disappeared for a second. I'm back, and let's get back to rocking and rolling on this. So we want to make a graph move method, which wants to do basically the same thing as our make move. I don't love that I'm about to do this, but we'll start from this. I'm gonna copy literally the whole thing. What do you mean is never used though? But because it's like it's literally used right below it. Is it just the fact that this? Yeah, no, you need it. Okay, you never move just because the method's never used? Why do you think you're never used? Feels like a lie. Constant's never used. 95. But if I remove you, now you don't know where to find this constant. So like that seems kind of hilarious. Huh. Super interesting. I'm not sure what it's mad about here. But like I can do the cheating way and just make it a variable. Why make it a constant when you can just make it a variable? I feel like that could have been the problem. Let's try this back again, just because I'm curious now. Was that all we needed? Yep, just was unused because it wasn't public and then I couldn't call the thing. Okay, let's run... Actually, let's do something else different. Let's go to here and let's go... Info... Let's do an info log. Graphing, Monte Carlo tree search. Just get a string out there to make sure that I can see it. Cargo run. Oops. Man, thought it would find the right one for me. Yeah, that. Oh no. Wait, what? Uh-oh. Okay. I didn't need log info. I just wanted normal info. Didn't realize that. Let's open a paw for making some network requests. I've done this with curl before, haven't I? But, let's see. Do I have a... Oh, and I have a hurl test for this. Hurl. I guess we'll make a new one. Add. Graph. Monte Carlo tree search. Hurl. Hurl tests. Graph. Graphing. Love it. Nice. Okay. Nope. Love it. Love it. Okay. So we have a basic place where we can do some graphing. We have a method, and it definitely logs, but it doesn't. And actually, let's do this. Just I brought it down. Bring it back up. Cool. And this one does not log anything. Yay! Okay, they're definitely running different code paths. Which is all we wanted to say right there. So yeah, let's figure out if we can draw some stuff. I guess what we want to do is just try to output some we just want to use our new our dot crate that we were looking at. We're not going to use dot actually on the other one. And start graphing our nodes. So like, where do our nodes live? There's our node, and here's our tree context. Awesome. So tree context. Oh no, tree context is this nested thing. So node, we just are gonna have a node as our root. So we want to just be able to say from a node, there should be like a graph method. So nodes. Yep. Okay, so this is where nodes can do things. I don't actually think I need my node to do things. I think we're just, yeah, like I don't care about any of that stuff. So we're just gonna tell it to graph it. We're gonna say we just take a reference to self because I don't know what else we're gonna take, and yeah. I guess we're just gonna, okay, so let's add this thing in here. Speedy battle snake rs cargo add this gen or crate. We're not in Ruby. Perfect. Took it a sec. Okay, so now I can say that it returns, actually, let's do this. It's gonna be mad at me, but I can tell it to cargo reload. Awesome, it's found all my packages, so now I might just be able to say dot, yeah. Gonna return. Implicit returns, yeah. Cool, cool. Okay, so now we have this graph method that we want to output a single dot thing. So we could do something like this. Import, this node's wrong. Yeah. I need that. Because I have my own node and it's different than this node. I kind of want to call, I wish I could do .avius as dot, but dot's a different crate that does similar things, so that just feels like not a great idea. Okay, so if we just pretend things can be graphed, which they definitely can't yet, but now I have my graph move, I want to actually do something with that. Okay, so let's just say graph move wants to take a, no, we will make it take like a directory and stuff in a minute, but not right now. Rust, write to file create, file write all, something like this. There's actually an easier way to do it. It's more efficient. Buffered reader. I thought there was just a kind of a helper for doing this. File read to string. I guess read to strings may be what I was thinking. Yeah, read to string exists, but if I want to just make one, we're doing it the opposite. Okay. So something like this. Foo dot dot. We're just gonna make a dot file. Foo dot write all. Format bang. I think it's just the actual output, right? Yep. Comma root node dot graph. Yep, file, sure. Yep, I also don't want to do that. File, you can import. No method write all. How about you just find the right import? Cool, mismatch typed. As bytes? Like I can do an as bytes, but that doesn't feel like what I want. Okay, that works. Cool. Cool. No such file or directory. Yep, okay. Kinda thought that might happen. Cool. Awesome. Okay, well, that outputted the right thing. So this is initial. And then this is expanded. Awesome. Temp and maker temp. Nice. Nice. Expanded. Nice. Okay, so do I have GraphViz installed locally? I'm gonna go with probably not. Love when it has to download OpenSSL and Python to install a package. I also don't even know if these are just upgrades, if these are new ones. Sometimes Brew does some interesting things. Those could all be about GraphViz though. Okay, let's let that run for a second. I think we actually want to think about how we do this implementation of graphing. In here, no, not in that. In our Monte Carlo, oh, we're already in the right file for that. Okay, but there's this graph method. This is where we need to do some stuff. Yeah. What are you? You're a graph builder? Okay. I think I might need to be able to take in a graph builder from here so that this can be recursive, and then from the outside, I'll just pass in an empty one. Or I could do it the other way and just make a graph, and then we'll have a graph with method that takes a builder. It's a graph builder. Well, this parameter, the return value are declared with different lifetimes. Yep. Yeah, hey, this is actually just self.graph with boop, boop. Awesome. Okay, so let's actually figure out how to use this. Graph viz dot to PNG. Sure, I don't really care what it is. Oh, okay, awesome. Dot TLDR on the dots. Render the output. Render a PNG with a file name based on the input and output format. Output. Do. It's interesting how this works, but that's okay. So dot dash, let's make a PNG from temp initial dot. Oh, I needed a dash capital O here. Cool, that was easy enough. Okay, so I have graph width now. So I think I need depth to talk about this. I'm not positive what I want to do here. Because I think so. We need to add ourselves. Okay, so I definitely don't want the build unwrap here. I'm gonna just say builder equals that. Mismatch type expected that found a mutable ref. Yeah, so what do you take in here? So does that work? Okay, so self dot children. Is this a ref cell of an option? Great. If let some children equals self dot children. Yeah. No, I need like that whole as borrow stuff. Do that. Okay, oh, it's actually not in graph move, it's in graph, but that's totally fine. Let children equal self dot children dot borrow. Oh. What is value here? Yeah, reference to a T, and the borrow's just the borrow ref. Got it. I don't need the borrow ref. Nope, you can't rename it like that. But I could probably dot 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 it. Let's not right now. Or C in children. Yeah, okay, so I can't really do everything that I want to do here. This expression has a type of that. Okay, yeah, so where do I... Yeah. Children.borrow. Yep, is some. Yep, sure. As ref unwrap. Borrowed. Children. Okay, so like I need to do something like this. Oh. Go to this method. Gotcha, perfect. Unwrap. I don't want that unwrap there. That's gonna give me the option. There we go. Child dot graph width builder. Oop. Depth. That's one. Let. Oh. Yeah. I actually don't think I want you to return anything. Let mutable builder equals mutable reference to builder. Oh, yep. Let graph equals builder dot build dot unwrap. Yep, and then we do it dot graph. Yep. Consider removing the borrow. Consider borrow of moved. Yeah, no, that wants to be a reference. Nice. Cool. Awesome. Okay, so does this still work though? So how do I do edges? I think let's see, because I think actually all it does is it's just the names. Yeah, so takes in a builder and adds itself and all children as nodes in the graph. Returns a string that corresponds to the name of the current node. Oh, wrong ones. Man. I was trying to. Oh, I see, because it was just mismatched. That'll help. Mismatch type expected struct. Wait, what? Cool. Yeah, fine. Just remove the return. Okay. builder.add edge. From source to the target. So the source is me ID as string. Target is child ID dot as string. Yep, add a semi. Okay, so the problem now is that all the children aren't, like, this isn't gonna work right. Yeah, this just like this isn't gonna do what I need it to exactly, but let's just build it and run it. Okay. Unused import borrow. Okay, that's fine. Just remove the thing. Woohoo! Okay, Pearl. Okay. Bat temp initial. Yeah. And then expanded. And this one's not gonna look right, but so many. Okay, so that's a problem. Everything. Wow. Oh yeah, 64 of them, I guess. Wow. Okay. Let's see what the hell happens if I try to dot that. I want expanded. Wow, it drew all the edges but deduped the nodes. That's pretty fun. Obviously not helpful, but that's fun. So what I need to do is give each of the nodes a special name so that they all look different. So let's try to do that. Do I just like throw a random number before him? How do I want to do that? How would I want this to look? App.excalidraw. Fine, let's just feel like I just haven't set this up yet, but we can just use this one. Oh, cool, look at that. This is actually kind of, this is what I did last time, and then I didn't do anything. Yeah, so I guess I can just do this. Like, this might be the easiest way to do it. It's not a great way, but it'll work. Let's go to my graph function. Graph width has a depth and then a, like, a child number. An option of a usize. Enumerate. And then the child. Nice. I think that'll work a little better. Nice. Dot format PNG temp expanded. Open temp expanded dot PNG. Poof, that is a file. That's a graph. Oh man, okay. Um, it worked. Man, that's a graph. Okay. Um, I actually might not have needed to pass child number there because I have the tree context. No, I still think I wanted it. Okay. Um, so now it has that in it. But like, do I want to add like the move? So it's like self dot tree context dot map. Yeah, so let's go to my tree context. Tree context has a move. Okay, so that's what I want. R that move, that needs to be that. That's cool. Oh man, told me what to do, but didn't want to do it for me. Cool. Wow, okay. It's working though. Like that was what I wanted it to do. Um Okay, but like I guess we should just give it some more information here. Like that's the whole point. So let's like label these, I guess, right? This is the depth. This is the child number, which like literally is meaningless. This is the move. And then I want like an average score probably. Nope, let's do total score. Let's do all of the total score. Visits, comma, UCB1. It's not comma, I want new line. UCB1 means I'm gonna need to do that, but that's okay. Average score. It's that. Now we need a lot more things. So move. Number of visits. UCB1 score. I don't have that yet. I guess I just need it. Total number of iterations. That's a U size. The problem right now is that it doesn't know that those methods exist because they don't exist unless it implements all of these methods. So I'm just going to move its block down to here because now it knows that it can call all these methods. Okay, so these things don't implement that, which is kind of hilarious to me, but they probably implement this. Cool. Yes. Total number of iterations. Total number of iterations. Awesome. Okay, this is actually looking better now. Like, it's still like an absolutely absurd graph, but like we're getting some information. These are all when I'm making certain moves. Yeah, okay. So let's just tell it to do this for a little while. Okay. Yeah, let's see how many it can make at 500 milliseconds. Doesn't sound like a crazy idea at all. It does, but that's fine. So at the end of this, after we back propagate, I want to do one of these again. Wow, that might have just been all I needed to do. This is gonna write a crap ton of files. Wow, okay, we made it through 57 iterations. So let's just take a look at some of them, I guess. Can I like OSX open dot files graph viz? Like, I just want a visual program that can open these. Does that work? Because that would be pretty cool. Like, can preview open a dot file? Yeah, see, I wanted to do something. Oh, nope. Yep. There's a graph viz GUI. That kind of sounds nice. I want the graph view GUI. Yeah, I know you're the graph viz, but what about the GUI? No, I literally just want something that can run. I don't even want an editor. I just want a GUI viewer. Oh, there's some Vim plugins for it. That's kind of cool. Graphical interfaces. Preview dot. That's for that. Don't have the best reviews. Yeah, I kind of wanted something just like that I could open on my computer. Graphical interfaces for OSX. Yeah. But does this mean it's just on the iPad? iPhone. Yeah. Okay. Wow, this is pretty old. Yeah, okay. Yeah, okay. I guess we're not doing that. That just seems a little harder than I wanted. Is there any of these that'll just open it? I doubt it. I just want to open these files in a way that's going to be easier for me to look at. Oh, wait, what does it want to open them with? Pages. Can you open a .dot file for me, Pages? Just go. Okay, so no, it can't. Wouldn't be so cool if Preview knew how to open a dot file for me. I don't think it does, but it would be really cool if it did. Okay, I really do want that to work, but that's okay. Iteration 1. Whoa. I just messed that up. I forgot to do that. Open temp iteration 1 dot. Let's see what happened here. So after iteration 1, this looks literally the same. Oh no, we got some scores up here. Okay. Oh, because it didn't expand anything, but one of these got a score. Which one? This one. The last child. That's fine, but, okay. I mean, it died, though. Okay. So what does iteration 2 look like? This is fun, except I really want a better way to open these. Our average scores back to 0, because I guess the next one we chose had a score. Okay. We're basically just gonna go through all of these. So what's like, how many iterations did we have? Oh, only 62. Well, let's look at 62. Yeah, so we're still on this layer, but now almost everything has a score. Okay. If number of iterations, total number of iterations, mod 64 equals 0, then we do this. Only for every 64. Awesome. Nice. Open 64. Oh, whoa, that's weird though. That doesn't look right. Or is 64 the last one that makes sense for? Visit 64, yeah. Okay, so I guess 64 is gonna be the last time. Yep, okay, so let's look at 128. Do we have, ooh, we've got some layers. This picture is hard as hell to follow. Oh, they also overlap. Okay, yep. Because that's not good enough. Like, the ID literally needs to be, like, based on all of the things before it. Interesting. Yeah, okay, so my trees collide when we expand them out again. So I need to, like, make the named nodes things a little smarter. Yeah, okay. I think it's really this me ID thing that we do down here. Oh yeah, me ID is this whole thing. What if this becomes a vec? Let new child ID equals child number dot clone new child ID dot push I immutable new child ID cool. Oh, is too large for Cairo rendered bitmaps. Oh, okay, that's fine. It just told me it scaled it. Holy crap. Okay. How about we make you an SVG? I don't know what it's gonna open in. Okay, that's fine. Kind of. Wait, what? Sort by name. There we go. Why? Wait, I'm pretty positive I can open an SVG in preview. Interesting. Why are you not able to, like, why are you pretending to not be able to open that? Oh, it doesn't want to open SVGs. Super interesting. I really thought preview would open an SVG for me without an issue. And this is actually opening it in Chrome even. What about you, Firefox? How are you feeling about it? It's also, oh, it is kind of scrollable. Oh, I see. There was a scroll bar down here. I just didn't see that at first. Okay. Well, I think this is right. I don't really think it's wrong, but it's definitely hard to see. And not all of them are expanded though, right? Like that's not expanded. There's nothing under it. Okay, well there's nothing obviously wrong here. Like everything looks pretty sane. But this is hard to explore. So one thing that I could do though is I could make it easier to explore by looking at something with less players. Because right now this hurl graph, this one was doing start of game, but like there's some others that I could maybe do. Wait a sec, how many players did I decide were in start of game? 1, 2. Wait. 1, 2, 3. So why is it 64? 4 to the third. Oh, okay. I was thinking it would be that because of that. But 4 moves to the third is that. But also, like, we really... No, I think... Okay, but in expanding the tree, I decided I wanted to look at all of them, which is how we get to 64 here. But when we're actually, like, simulating, I decided not to do that. But we don't actually graph anything with the simulation. But I should still be able to make this a lot smaller by making this a 2-player game. The easiest way is just to cheat. Woohoo! Do I have more this time? Not really. Refresh. Refresh? Okay. It's all the way over here. Still 63? That's kind of interesting. Unless I did something wrong. Because our hurl is using that one, right? Hurl, start of game. Start of game has 1, 2 snakes in it now. So that should be less. I need to go grab myself another drink, so I will be back again in just a minute. We will debug why we're still getting 63 in our first round there. Maybe this didn't actually change like I thought it would, but still need to debug why we're graphing a little wrong. Be back in just a second. And I'm back. Thanks for hanging out with me. Okay, so I want to figure out what's going on because I thought I just changed the fixture to only have 2 snakes. With 2 snakes, we should only have 16 children for each of our children thing. So like, why didn't we? Our temp directory still has all of those. So now we'll run dot, make an SVG out of, let's try 64 first actually, because 64 is even actually going to be kind of a lot in this case, because we're not doing quite as many cycles. Not as many cycles. There shouldn't be as many children for any one thing here. So we actually shouldn't get to child ID 17, 18, 19. Like, interesting. Why are we still getting to 64 children? That's pretty interesting. I can't explain that. But I would like to be able to, because that feels wrong. Yeah, something just isn't right about that. Because start of game, it has a U, it has a board, that now should have 2 snakes. 1 snake, 2 snakes. And that's it. So how are we still getting 64 children? That doesn't really make sense to me yet. Because our graph runs the start of game fixture file. Okay, so let's go and figure out why we're getting confused. Num players. Yeah, actually, I forgot that I can do this. Player count self dot self dot game get snake IDs dot length. Yeah, player count's 3. Why is player count still 3? Yeah. No, how do I... Player IDs is actually not going to be helpful at all because it's just going to literally tell me the... Yeah, that's what I thought. Did I like edit a different fixture file? Is that what's happening here? Yeah. Perl tests have their own fixture file. Great. Oh, because that's all the way in Battlesnake RS and then fixtures. Got it. Okay, well. Okay, that at least makes sense. I don't love what I've done to myself there, but it at least makes sense. I can delete this from there. Oh, actually, yeah, I need to change that now. There we go. Cool, we did make it farther. I was just wondering if we would. Let's open 64. Okay, we have some different depths now. we look at our depth 1, yeah, only 16. And then this one, 1, 2, 3, 4, 5, 6. How does that only have 6? That doesn't make sense. One, 2, 3, 4, 5, 6. 6 isn't divisible by the right things. So up, 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 down, down, down. Okay, so what am I doing for expanding? And am I doing the wrong thing? Up, up. I'm looking at the depth 1 directions. Up, up, down, 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 left. Yeah, okay, so we do touch left here. Left, 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 right, 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 right. Oh, and there is some, like that one goes out to 9, right? Up, up, down, 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 left, left, left. Okay, so what am I doing in expand? And why do I have a different, like, my expand seems like there's something. There might be something up in expand. What is it doing? We're at the end, don't do anything, but that makes sense. Simulate. So simulate will only return valid things? So is that what's happening? Is that simulate? Like simulate doesn't return all the moves, it just returns the ones that are like legal or something like that. The ones that don't end in end states. But is that what I want for expanding? It kind of feels like... it kind of feels like both it is and it isn't at the same time. Because I also do simulate with something else later, right? Yeah, then I call simulate with moves, but that's in my... Oh, well, that's in a test. I don't care about that one. Oh no, here's this though. Okay, yeah. And there's where we call simulate with moves, and we call random moves, random and reasonable move for each snake. Yeah, okay, so that all makes sense. But when we expand it, we just call simulate. And we don't pass it anything. Okay, so I guess what I want to do then is look here at the types. Okay, so simulate literally just already does all the moves. Moves to simulate as slice, passes it into simulate with moves. Okay, so there's not really anything that I can change there. Producing a list of new games along with the moves that got to that position. So something that I want to understand, and I think this means I need to look at the exact representation that we're doing. Okay, so simulate with moves. Perfect. Snakeadies were simulating. Cool. This is where we... Yeah, so here's where we're filtering out moves. Okay, yeah, and okay, this is the bit that's happening. We filter out moves that would kill our snake immediately. Or kill the moving snake immediately. So that's what's happening here. So in the second depth, there are moves that not all snakes are gonna survive. And we don't do them at all. Okay, so that's why we don't always have the same number of children. So I guess that's not a bug. That feels right again. And that's like, as we wanted according to the game types repo. It'd be kind of cool if I could like click to expand and despan these. It would also be really cool to get the them like to animate between the things. But that might be a thing to do next time. Yeah, okay, but these have UCB, like everything's working. So yeah, let's see. We did this earlier. Let's just check out the global arena. Games are still running, but have we been doing better in our last games? No, we have not. Oh, we made it to some high turns, but like we haven't been winning. Or actually, the game made it. Did we? Okay, so it'll be interesting to see in a couple days. Oh, see, that's like some of these moves are interesting though. Like, wouldn't left or right been like just a way better move from there? Like, if we want to look at turn 43 here. Wrath, body, text, JSON, post. Okay. Nope. Awesome. Awesome. Let's actually rf my temp directory, make dir temp directory, run you again. Awesome. Okay. I guess let's just look at 64 first. Okay. Oh yeah. Okay, so this though makes sense. Okay, so at the moment, total score, we've got lots of zeros, some ones, some negative ones. Okay, so let's keep going. That was 64. Let's do 128. Okay. Got depth 2s with no score. Depth 2s with still no score. Yeah, but actually, I guess I want to look at depth 1s that have scores. The average score is 1.0 there. Average score is 1.0 there. So I guess I would just pick one of those. That's interesting. I wonder if there's a... I guess if the average is the same, I'd rather take the one with more visits? Probably. Yeah, like that one going up. Oh, actually, that's the way I ended up going. And that's the way that killed me. Oh, but see, but this time I went right. Yeah, and that's the thing. It's not gonna be consistent. Which just makes Monte Carlo a little bit harder to debug, I feel like, because it's not gonna be consistent every time. Like, even if I just do this, yeah, eventually we'll go up and right and then left. Which, like, Just makes it hard to debug. I don't have a reason to believe that that was the wrong thing to do, but it also doesn't seem like the right thing to do necessarily either. Left or right seem better than up. Lots of the times if I go up are gonna be death. There's really only 2 here, which means 50% of these should end in death if I go up. So like, why? What did my graph say? Is that what it says? Because it kind of doesn't feel like it. See, this is when I need my graph to be like clickable and expandable. Because I kind of want to hide all of the depth 2s right now. Yeah, so if I go left, I've got a lot of -1 total scores. Oh, interesting. Total score 1. Yep, okay. But the average score there is still pretty low. So is it interesting that my... So my scoring algorithm right now is that a win is the same, like, you know, a loss and a win counteract each other. But I wonder if that's what I want. I wonder if I want wins to be way better than losses. Because like this one, right, as an example, total scores 0 with 2 visits. Is this 1 win and 1 loss? Or is this a win and a tie? And I don't really know that. Oh, well, there's an average score of -1, so there's a loss, which means there's got to be a win somewhere. No? Guess I'm just doing it this way. So I'm trying to figure out how the average score worked here. Maybe I'm graphing something wrong or I'm missing it, but I didn't actually find a win. I just saw a loss. Yeah. Okay, so there's the -1 with 1 visit. But I didn't see another thing that would make the visits 2 on my top node. Oh, that might actually make sense though. I'm gonna need to go back to my notes in just a second, but I think that actually might be right. Yeah, okay. If we go to my notes, we expand if we're looking at a node that we have already been to and is a leaf node. Yeah. Okay, so that's why. We will do a rollout the first time we visit a node, and the second time we visit a node, we do an expand, and then a rollout. So it actually makes sense that we've only seen 1 child that's been visited, even though our parent here has been visited twice. That still doesn't answer my question about my scoring here, and whether a win and a loss are equivalent. If I make them equivalent, I think the ratio there of loss score to win score, the bigger the difference between, like, the, you know, if they negate each other, right? If it's -1 and 1, I'm kind of right in the middle of preferring safety over wins. If I make losses like -2, then I'm trying to imagine what that would do to the equation here. I feel like I don't want to make wins better, because then I'm just gonna start diving into things that I could win but probably won't. Yeah, that is definitely right there. That makes sense, at least to me at that point. Okay. I want to commit so that I can get a profile in the cloud. I'm kind of just curious what we're spending time on here. But oh, I'm actually not going to get a profile in the cloud because there's like almost no way I have a benchmark written for this. Yeah, I just totally don't. Add Monte Carlo tree search.rs. Monte Carlo tree search. Monte Carlo tree search on a compact board. Monte Carlo tree search. Monte Carlo tree research snake. Yeah, I don't need nearly that many arguments. It takes a game and a game info. Perfect. Black box game info. None of those matter. You don't matter. Deepened min max bench for 3. Yeah, okay, so I want like Monte Carlo tree search bench for 3. Yeah, then this is basically the exact same thing, except for game. Can do that. Nice. Yep. Okay. Yep. Okay, so now I want, what did I call this thing though? Monte Carlo research bench. Yep. Okay, so Monte Carlo research bench. Oh, okay, so it's what's in make move, but I want to move it to somewhere else. Ugh, so much copy paste. I'm gonna have to clean this up soon. Monte Carlo tree search bench, max iterations. There's a U size. Don't need that. While total number of iterations is less than max iterations. Keep going. What's up with that though? Oh, okay, because I put this on node. I don't want this on node. There we go. Cool. Gotta make it public. Cool. It's now public, so I should be able to run that bench now. Awesome. No cargo. Monte Carlo tree search. Yep, yep. Monte Carlo tree search. Add a method and API and point to graph the game tree. The diagrams work, but really need a better way to browse dot/graph viz files. Also added a benchmark here so that I can start getting profiles in CI. And like what I guess I really should have done is tried to like, you know, run benchmarks. Let's see if this works. Just want to make sure that I can actually run these benchmarks before I push them up, though I think I can do benchmarks locally. I don't think I can do profiles locally if I remember correctly. I also have no idea how many things I told it to do. That's a great point. Like, what am I actually... Oh, 3? Yeah, that's not gonna work. Like, it's fine, but like I want something closer to like 1,000 iterations, or maybe even 10,000 iterations. Because this is just gonna be super duper quick, like way too quick. Yeah, it takes like some amount of nanoseconds. Yeah, let's run this again with 10,000. Because that'll be a lot better. Yeah, it's gonna run like for a minute now. That's better. Let's see how long it actually thinks it takes to run 1,000 iterations here. And then what'll actually be nice is I will want to plug this into I'll run it on Circle and we'll get some profiles, and with the profile data we'll also get some flame graphs, and that'll be really fun to tell me where my Monte Carlo is spending time, and I think it'll be very different than what I've spent time on min-max. In min-max I've always spent the most time in my score function, but in Monte Carlo I think I'm finally going to be limited to the game types repo and simulations, which is fun because that's something that me and Penelope have both spent a while optimizing, and in min-max it was okay, but I didn't get the most benefit out of this. It'll be really nice to do it this way and see, you know, how much of a benefit I get from the game types being super duper optimized. I guess I don't really have it before because it already is super optimized, but still, I think my profile will show that I'm spending a lot more time in those simulation methods, on, you know, in average, or, you know, oh yeah. We want this to run for a lot of iterations, not just 3. Yeah, this is just very different than min-max, where min-max that was a depth. Monte Carlo doesn't have a set depth, so it doesn't really make sense to talk about it in depths. It's just how many iterations you ran. And we want a very different number of iterations than 3. We're at 10,000 at the moment. What's also interesting is that it does seem like Wrapped is gonna take longer. And I guess that makes sense, because I guess in a standard game mode, your options are more limited. You can't, you know, if you're at a wall, that takes away one of the options that you could normally take. But when you're not when there's Wrapped and there is no walls, the number of options is always bigger. Yep, so Wrapped did take longer, an extra 200 milliseconds to do the same amount of work. So that's interesting. That does make sense a little bit. I don't want Chrome. Pipelines, coreyja. Oh, come on. You know who I am. Me. Rattlesnake. Awesome. Oh, did I tell it not to... Am I not profiling every PR anymore. I think I'm not profiling every PR anymore. Oh, I need to put profile or bench in the name. Okay. Um, bench profile. Bench profile, bench profile. Awesome. I forgot that that's how I set it up. That it kind of does make sense. I have to like opt into it. There we go. I've opted into it. There we go. We've got profiling going on. That's the one I actually care about. I do think it's gonna take a while, but you know, it is what it is. Like I kind of want to wait for this and see, but I also am pretty positive it's gonna take like 15 minutes. So either we will hang out and do something else and hope that when we get back to it, it is ready to go. Yeah, okay, well, the other thing that like we haven't done at all at the moment, but like I really want to, is I want to think about how this is organized, because it's not organized very well. The bench function is literally the same as our move function, except for the fact that we just aren't doing this. That this while loop is the only thing that we changed. Okay. So I could refactor this. So like, we could take this bench function. We're gonna duplicate it for a second. So we're just gonna call this Monte Carlo tree search. It's not gonna take this, and this is gonna be the while condition, which is a function of a usize to a boolean. Yeah, I just don't know how to make, yeah, some function. Cool. While condition following it on total number of iterations. Okay. So it doesn't like that, but that's okay. Let while condition equals how do I write a closure like this? I actually don't know how to put a closure just like right here. Yeah, I actually don't know what to do here. Total number of iterations as a usize. Number of iterations is less than max iterations. Max iterations. Yeah, that's all. Rust closure as variable. Yeah, that's what I did wrong. Cool. Okay, what are you mad about? This doesn't have a... Okay, cool. So I just need a reference. That's all you're telling me here. Perfect. Well, that was easy. Okay, and then like the other thing I want is let's start variable. Not that, not that, not that, not that, not that, not that. Nope, nope. Okay, what file did you collapse? Nope, not the lock file. That's not the one I want. Files. I guess this one will work. There we go. Yeah. These. Um. Cool. Nice. Okay, so that's nice. I've extracted so that both benchmarking. Let's actually run a game with this to make sure. But what we tried to do here is make it so both benchmarking and running actually are going to use the exact same code paths, which is nice. Awesome. It's at least running. That's all I was really looking for here, making sure I didn't break anything, and it's taking exactly how long it should at this 400 millisecond mark. Awesome. Cool. Okay. That was nice. But the other time, I do have another place where I repeat almost all of this. And that is in our graphing thing. Okay, yeah, but it's not like that graph. I don't actually remember how I named anything, which is always a great time. Okay. I also need to like move things so they're in a better spot. There we go. It's graph move. And like all I really care about is those, and like I could just put this in my while condition. Okay, let's do this. Yep, I like that. So let's find make move again. Yep. Yeah, let's take the entire body of make move. Go to graph move. Comment all of you out. Um, I don't have root node. Okay. I can give it to you here. Like, yeah. Okay. Yeah, okay, well that's another thing I need to do up here. I need to make you take in a T. Where are you defined? Yep. Okay. Yeah, I know I supplied 2 arguments. Ah, yes. Reference to a node of T. And then a usize. Okay, I assumed not. That would have been crazy. Oh, okay, yeah. 169, that just needs an unwrap. Wow, pretty close though. 149. Oh yeah, all I need to do is tell it this one needs the other one too? Nice. But I'm leaking node into the public interface. Oh, that might be easy. This probably doesn't want to be public. That was nice and easy. Yeah. Wow. That was a big cleanup. Like, that went from being, like, pretty ugly in how much I repeated code to having no repeated code. Oh, look at that. Same amount of time. Everything's looking great. Awesome. Awesome, awesome, awesome. This is going to be a nice diff. It's just going to remove all kinds of stuff. Yeah, so our bench one just says the while condition is based on number of iterations. Our graph move says it's time-based and we do some crap in the middle. Guess I should test that. Oh, graph move needs some cleanup there, as in I just didn't delete all the crap at the bottom of it. Boop. Awesome. Bench, graph move. Yeah, so I guess let's do that. Let's make sure graphing still works. Yeah, that looks like it's gonna work. Yep, look at that. Ooh. I just like that curvy line right there. We made it to some depth 3s here. Yeah. Okay. It's at least working. I definitely would like a better viewer for these, but that's something we can work on separately. Slash another time. Awesome. Okay, so that code collapsing was really nice. I'm really happy with how that came out. Removing a lot of duplicated code. I do think there might be places where I've done this too much now, like does make move. I don't think make move needs this on it anymore, and like graph move needed on it, and the answer is like probably not. Oh, and bench, does bench need it again? Probably not. The reason to do that is because I pay honeycomb per like trace, so if I remove them, that's better. I can leave this in because we're never actually going to run graph move and prod for the most part. I don't even have a way to get to the things if I did. Oh, let's see what's going on with that before I... Oh, cool. I finished. Only took 14 minutes. Nice. We took a little longer than I thought, which is perfect. Profile data, artifacts. Well. Oh, I bet I ran the thing and then didn't upload the artifact? Is that what happened? Kind of. Yeah, I just don't have the bench line in my circle file. That's unfortunate. So it's just profile? So I actually probably ran benches for them, right? Yeah. Can at least look at that. Let's see, they ran artifacts. Yeah. Okay. Awesome. That's about what I got locally as well. A bit slower, but about the same. They definitely have some tailiness to it, right? That's interesting. There's a longer tail there. But yep. Reduce the number of copy pasta that we need by drafting way to call into Monte Carlo tree search with different closures to determine what it's up. I also changed the bench thing there. Oh, cool! I get another chance. Also make it so profiles run for Monte Carlo research in circle. Okay. That should have picked up over here. Nice. I guess we can do this in GitHub because we're basically going to take this. Can I like edit this to be a different branch here? No. That makes sense because that would like be like weird, but I wanted to see. Yep. Yep. Supersedes. This one. Had to change the branch name so that we would get bench and profile data in CI. Supersedes. Let's create a real PR. We get to close you. You're the new one. Woohoo! Let's look at what this diff looks like now. Okay. Oh, typo. This wants to say Monte Carlo research wrapped. I thought I checked already that there wasn't any hops in that file, but I guess I didn't do it well. Yeah, better. But now I like almost don't want to push for a second because it'll be better if I don't. Oh yeah, and in Graphland, did I decide that I feel like I did. Yeah, in here I decided that we were always going to be standard. Let's write a comment there. Yeah. If gameinfo dot I don't actually know what we have here. Rule set. Assert not equal gameinfo dot rule set dot name. Nope. Drafting does not currently support draft games. Insert not equals, yeah, if we have wrapped, graphing does not currently support wrapped games. Yep. Yeah. We just want to be explicit with that so that if we accidentally did it, it would blow up on us because we didn't support wrapped there, which is pretty fine and reasonable. I'm not upset about that. Yeah, I think I want to check out the new, like, check out main, oh wait, yeah. Nope. Copy. Perfect. Yeah, I didn't really want that change. That was just for me testing locally. We have some more imports. This I just changed to be explicit about that. There's really not much I changed in actually Monte Carlo, but I guess that's hard to see because I don't have that diff. This is just everything, and the whole file's collapsed, isn't it? That's why I don't see anything, but it's definitely here. Yeah, there we go. 600 lines, it just collapsed it on me. What I really should do is break this apart into separate structs, or they're already in structs, maybe I should move things to separate files. Like things about the tree, like my node things could probably move somewhere else. Yeah. That wouldn't be crazy. But I also don't really know if I feel like it's super necessary yet. I think if I did it now, I'd just be doing it a little too early where I don't actually know how I want it to do that yet. So yeah, I think we're gonna leave that. Fix some typos and undo changes I decided I didn't want. Like the fixture change. Boop. Awesome. How's circle doing? Circle CI is doing good. It's been running for 6 minutes. It took 9 minutes last time, so we're getting pretty close. Oh, profiling's done already. That's the only one I actually cared about here. Let's see it in this mode. Okay. Here's Monte Carlo bench. So this is where I'm at. Spec from iter. Choose a random one from a range. Add vex eventually in here. Okay. Oh, ooh. Impl AVX. Oh, that's fun. That might be some of the SIMD, single instruction, multiple somethings that I tried to mess with a long time ago. Son of our as use size from my 32 vec move. Okay, so interesting. I think with iterators it's actually going to be just a tiny bit harder for me to see where everything's happening. But here's the eval moves with state, assert consistency. Yeah, iterate last. Interesting. That's the multi-product one here. Cool. Oh, some Maliks in there. Guess I'm not surprised. Malik. I thought there was something that kind of looked interesting here, but maybe not. So this is an evaluate with state. Yeah, okay, well, so the cool thing here is that, like, we are really hitting all of these things really hard. And here's simulate with moves. Generate state, yeah. Instant.now. Oh, interesting. Like, I spend an unreasonable amount of time calling instant.now. Yeah, here's my expanding. Expanding's not the most exciting there. Next leaf node from my Monte Carlo. This is just pulling things off of that. Okay. So yeah, we're like just really all in the simulate code, which makes a lot of sense. Like there's really not a lot that we wrote for Monte Carlo that isn't just simulating moves. There's some things that are interesting to look at. Like I know this is only 3% of my sample, but calling instant.now is interesting. Yeah, only 4.3% of it comes up to that though. So like it's not that crazy. Like if I do with state, that one's 25% of it. Yeah, okay. I want to know what this one is. So it's just from bench. We immediately call choose. So this has to be random reasonable moves for each snake. It's just kind of like has to be, right? Yeah, because I'm doing lots of adding to vectors, and this is generate a range. Yeah. And it does need to be randomized, because if we don't randomize it well, we will just, like our Monte Carlo, like that's part of what makes Monte Carlo like great, is that it randoms this. So I kind of wanted to like get rid of the generate range there, because that takes like a decent bit of time, but we can't do that. Is there a different RNG? Yes, there is. Simple and fast random number generator uses this, but not cryptographically secure. Yeah, I don't need a cryptographically secure thing. So, and I think I have a thing where like I just pass in a random number generator kind of from the top of something. If we look at here and I look for RNG, yep, I know I simulate with one. So where do, yeah, in Monte Carlo tree search, I just make one. So this could be a really easy one. Okay, fast rand is added. Fast rand, like what if I don't know what I want? Oh, to be more efficient, create a new random instead of using the thread local generator. Okay, love it. Yes, okay. Yeah, because I told simulate that it will always take that, but I don't want that anymore. So simulate 115. Go to definition, a reference to a dyne RNG. Trade implementations. Yeah, okay, but like, isn't RNG a Rust RNG trait? Isn't that a trait? Or is it not? Yeah, oh. Oh, wait, Rand RNG. Rust. Red RNG. Oh, okay. So does fast RNG implement this trait? Reference to a dyne RNG. Trait rand can be made into an object. Can't be made into an object. Um, Oh shit, yeah, no, I can't do that there. I didn't realize that I was where I was. Oops. Cargo builds. I want you to tell me where my errors are. 115 in Monte Carlo. So does fast RNG not implement RNG? Because like I get it, but that would not be helpful. Yeah, so it doesn't seem like it implements what I needed to implement. So like that's a little annoying. Uh do. That implements the random trait. Like again, this isn't the RNG random trait. Like so what the hell? It feels like I want to use this thing. Like this is just yeah, like I want to use Rust RNG. Um Yeah, so like I get this, but I don't like the fact that I want a fast random number generator, but I still want it to implement this trait. Oh my gosh, am I gonna have to like I could try to do that, but that sounds like not the most fun. librs random. Yeah, like this is what I want. I want fast rand, but I don't like how fast rand doesn't. Interesting. Is there features that make it be a rand? Definitely doesn't seem so. It seems like something that wants to infect everything. Like I just want, yeah, I don't like I want you to depend on rand so that you implement the right thing. It's like you need to implement rand. Okay, well, I guess this is probably not going to work well then, because fast rand isn't going to play nicely with the thread random number generator that I need. Like maybe eventually I could like make fast rand take, you know, like that it will implement it. Like I could re-implement it. Oh, I'd have to make a wrapper too, wouldn't I? Ugh. But yeah, because I don't own fast rand, I'd either have to fork fast rand or make a wrapper type locally around fast rand. The wrapper type wouldn't be awful, but it would be silly. That's probably what I'd go with. But you know, I'm not sure we're gonna do that today. It's a fun thing to think about some other time, though. There we go. This worked with some profiling, got some artifacts. Oh, okay, so yeah, this was still that one. Cool. Yeah, it's about the same stuff. We see instant now. How much does like rand show up? That's not too bad, really. 7.3% for RNG. That's not too awful, but like, I don't know, taking 7% off wouldn't be bad. I do feel, I think that's interesting. Yeah, why is now so like, there's got to be a hot path to call now that I think I could get rid of. Simulate with moves keeps calling now. But I don't think it needs to. But yeah, I think this was a good stream. We got some good graphs. Let's see, do I still have any? Yeah, I do. Let's open this SVG. Yeah, so these graphs look pretty decent. Like, I think I could add some coloring to them eventually, maybe. And I really would like a way to, like, not have to render the dot files. And, well, like, I would like them to be rendered, but then I would like to be able to, like, step through them. Not have them auto-expanded, and things like that would probably be really, really nifty. But we at least can get some SVGs generated here. Oh man, it's so hard to tell where these ones come from. Here's the where they break off. You can tell from the child ID thing. Because that, you know, we go from 0 to 1 here. So yeah, this is definitely not the prettiest diagrams, but they're here. And they can kind of help me see the tree. It's kind of like I can see it if I'm looking for something very specifically. Can I like search for things? Ooh, I can. 0, 2, 3. Yeah, okay. So that's nifty. Since it's an SVG, I can like actually search through it and pull the text out. So I think that's useful. I think there's definitely some potential here in this graphing. But I think I would need to improve it to make it super duper useful. I think I also need a push here. I think there's some changes that I need to push up. But I think we'll wrap up. Let's actually check in on how Monte Carlo's doing in real life here. I'm not sure. So we made some bug fixes that I was hoping was going to be like really, really helpful. But I'm actually not sure that really happened. We're gonna have to see how this round ended. Oh, this win's gonna be a little boring. I don't like short wins. But let's see what happened. Oh, took some people out. There we go. Oh, moved out of bounds on a timeout. Oh, that's interesting though. That was definitely like a 500 style timeout because it was going so fast before. Okay, well, thanks for hanging out with me, everybody. Hope you had some fun. I had a lot of fun getting some graphs working and iterating on this Monte Carlo tree search. Tune back in next week where we'll maybe be working on some more Monte Carlo things, or maybe we'll find something else fun to mess around with. But hope to see you then, and thanks again for hanging out with me. Bye for now.